All right, everyone, welcome aboard. So, recap of yesterday. So yesterday, what I did was I kind of redesigned or redid how I was imagining the walls of the structure in preparation for structural. And structural is definitely the name of the game today. All the design stuff is approved and out of the way. So this is what our tiny house is going to look like. And what we need now, I need to figure out studs in the walls. So let's open this guy up for a second. So now I have my oriented strand board on the inside, siding on the outside, and on the inside we've got a pine slat. It's the name of the game. So I need to get smart on how how a structure for like any building would work, but particularly tiny houses. So let's figure that out. I did a little bit of research on how that works yesterday. 2x4 wall studs, 2x6 rafters, that's about what I expected. Really, I'm just looking for an on-center spacing for the stud spacing in the walls, because that's going to help me determine how much lumber we're going to need and get a more accurate pricing. 2x4 wall studs set at 24-inch centers. So sit directly above the stud. There's no need for a double top plate, just a single. Instead of placing trimmer studs at doors and windows, we use Simpson metal angles. Interesting. Okay. So the name of the game is 24-inch on-center studs. I think I'm going to try and do this whole wall at once. Let's see. I think that's a little more in depth than what I was gonna do. So it sounds like, for my purposes, the uh, the floor joists for the top floor, which are going to be 2x6s, are going to rest right on top of the studs and run lengthwise that way. So think about how that might work. So we're basically going to end up with something kind of like this. I think I still have I may have purged out the structural layer. Let's add that back in. Structural. And I'll draw on that one. So let me think about this. Well, it's not more about stability. with a tiny house. It's more about this thing has to be mobile. It's lightweight. So the assumption is that this isn't a full-size structure and it's not going to be supporting its own weight quite as much as it would if it was a house. So 16 on centers, I think, is code. Well, my limited knowledge, I think, is more like code uh, for a non-mobile structure, but trying to minimize weight and minimizing design costs. So part of the advantage of building this on a trailer is we can kind of get away with things that wouldn't necessarily be to code. But that is a good question, and honestly, that's a question that I need to find the answer for myself because I yeah, I don't actually know the answer to that. I'm relatively new to this construction business, but life in pain. I mean, that seems like an educated question, which leads me to believe that you know a little bit more about this than I do. So, I guess what do you think? Because my knowledge is for sure limited. 3.5 inch. Just gonna kind of draw a 2x4 here and sort of play out how I might make this the interface for the second floor. This is gonna be. I need to I need to actually look up the actual dimensions of a 2x6. One and a half by 5.5. There we go. So blue axis 5.5, red axis 1.5, blue axis 5.5. Surface there, push that out. Can make these both groups. So what I'm wondering is if this is going to be, yeah, I guess I just don't know so much about how I'm going to support that loft. So the floor of the trailer, that's a question that I have done a little bit more research in. The way that this is actually going to be laid out is there's going to be this tiny house specific trailers have a little slot for wood boards, and it's like a wood board decking all the way across, and you can actually screw right down into that. So yeah, the base, so the bottom of the 2x4, like is basically the wall structure itself is going to be kind of its own unit, and we'll screw that down. We'll build it separate and then screw that down into the deck of the trailer. So that's the idea anyway. Let me just look up a tiny house trailer for you. Tiny house trailer. See if I can get an example of that. So basically there's a space in there to run boards. That would be, yeah, I need to do a little more looking into that. But I think the way that they'd be secured to that is possibly self-tapping metal screws that would secure the board down to the trailer itself. But my understanding is when you order these tiny house specific ones, they come as a unit. Let me see if I can find the one that I did. Can't remember the name, but I do have it here. Tiny House Basics, that's it. House Basics trailer. So I already sent them an email and got a quote for a 28-foot trailer. It's interesting. I was under the impression that these had a wood deck already. My intention for the plumbing, and I do have some of that planned out. So the gray water tanks. So black water is not going to be an issue here. We're using a composting toilet, so that eliminates one mode of or one type of plumbing. Gray water tanks have to be below the level of the shower pan so it can drain, but I have two of them mounted to the bottom of the trailer here, and the ones that I selected are at their biggest. They're about 8¼ inch, I think 8¼ inch height. So they don't stick out too far underneath the trailer that it might strike something when you're cruising around on the road. As for plumbing, the plumbing system is going to be relatively simple, but it's mostly going to be in the walls to answer your question. This is it's a tankless water heater, and the main source for water is a 50-gallon tank attached to a little, like a 3-gallon per minute pump, which is going to supply pressure to the house. It's like a pressure demand-based pump. So when you, it's always keeping pressure in the lines running through the walls, and then as soon as you open up a tap, the pump has a little solenoid thing that detects the pressure decrease and automatically starts pumping. So that in combination with a cutoff switch. But yeah, to answer your question, pretty much all of the water is going to be in this wall over here, but coming from this tank and then going out to the kitchen sink, washer, dryer, and then the shower. And there's going to be one that has to run all the way through to the bathroom sink on the other side. But I'm going to keep that in the walls of the house rather than underneath the trailer because it's a little bit difficult to insulate down there. And so, yeah, with the exception of the gray water tanks, all of our water is going to be in the walls. The walls, floor, and ceiling will all be insulated. So if you take a look at this trailer, I think the trickiest part's actually going to be insulating the trailer. Let's see. But you see these ones where it has the kind of the plate welded on the bottom of it, so all this space in here can be insulated. That's probably going to be foam. Yeah, there's a bunch of people or a bunch of different companies that actually do it, and it doesn't seem to be that much more pricey than a regular trailer. It just has a couple little options on it. So the trailer that I picked is 28 foot. It's good to 20,000 pounds. It's actually the one we were just looking at right here. I think it's good at 20,000 pounds. I need to refresh myself on the number that was all the way on the top of my list. So it's been a while since I've looked back at that. Options. Yeah, I guess it doesn't say. But here, 21,000 pounds, triple axle. And yeah, I'm pretty sure that you can run boards across that. But that's something that I really need to find a solid answer. So let me jot that down. I don't. A lot of people will rent U-Hauls, like the big, it's like based on an F650 frame, big box truck, and they'll tow it with that. There's actually one like Instagram tiny house couple that is sponsored by U-Haul, and they use a big U-Haul truck to tow it everywhere. So that's what I would do. Something that's rated to that 21,000 pound. Maintaining my own vehicle to tow this would be um, not really. So the point of the tiny house is not for it to be mobile all the time. One, you get to kind of skirt certificate of occupancy laws to like most places won't give you a CO for a um, a house under a certain square footage, and this would certainly be beneath that square footage. But also, it's going to stay mostly in one place for a large portion of its life. Basically, you put it on a property, jack it up with these scissor jacks that are bolted to each corner so the tires don't dry rot quite as easily and the bearings don't get flat spots. And when we want to move, an opportunity a year or so down the road happens, we just, grease up the axles, hook it up to a U-Haul, and tow it across the country. So the question that I need to answer, how do you attach the tiny house to the trailer? Um, I'm not sure I understand the question. Um, so there are some people, I mean, the idea is that in theory you should just be able to hook this up and tow it every day if you wanted to, but that's not the concept that I'm going for. So, but yeah, a mobile home in the sense are usually not structured quite as much like a normal house. They're more designed to save weight because fuel economy and whatever is going to be more of an issue. But for this, I'm cool with making it a little heavier than it needs to be because when we do move it, we're only going to move it a few times in its lifetime. I mean, the plan is to do something out in Pennsylvania, do that for a couple years, move out to Colorado, and then like Arizona or whatever. And it's just it's cheap to build, it's easy to move, and you're not locked down in one place like you would be with a normal house. You just have to call ahead, find somebody who. We actually have a friend who has a ranch out in Colorado, and he said, "Yeah, sure, you can come out and park your tiny house on it." I hope that answers your question. Yeah, so I worked as a CAD draftsman for a while, and all like the pre-made tiny house ones, I figured it's not quite, it's not exactly what I want. So I might as well put my skills to work to get exactly what I want. And frankly, I think that with a little bit of just practice, I mean, anyone can use this. I'm not fancy. I'm just using the web-based version of this program. I don't have any of the extensive tools or anything. But yeah, I've been having a lot of fun with it. The engineering challenges of like, for example, having a 50-gallon water storage tank underneath the sink, or the wastewater, not wastewater, gray water, which will ultimately be used to like water a garden because it's just as long as you use biodegradable soaps, it's good water. It's not potable anymore. But yeah, it's a lot of fun. I would definitely, if you're gonna live in a tiny house and this is gonna be your house, you might as well make it yours. And that's my theory there. So how do you attach a tiny house to a trailer? Metal barrier under the subfloor. I'm gonna take some notes on that. A couple different materials that can be used. So what I'm thinking is they probably have the trailer that, uh, let's see, this one where the deck is mounted to the bottom side of these cross beams, so that you can insulate that space, and then you put a metal barrier over the top of it. On tiny house, we've added a steel flange and replaced the wood decking with 2 steel runner beams. These combined changes total up to 4 connection points. 20-inch trailers may be as many as 48 or 20-foot trailer. Okay, so it seems like what they actually want you to do is drill right through those flanges and connect the structure of the house just right to the, like a, I don't know, just big old lag bolt going right through the wood. Metal barrier under subfloor, and then um, bolts, carriage bolts. Carriage bolts through the flanges. So that's definitely something on my list to do as part of the structural. But other than that, it seems like you can just kind of, yeah, for sure. Yeah. The other thing about this is, I mean, you have to design it to when it has to be designed like a hurricane house. We're using hurricane ties on all the pieces of wood, all these joints. I might not actually put those in there in SketchUp, but um, and yeah, it's got to be super secure. It's like designed to withstand a hurricane and an earthquake every time you drive it. So yeah, I already put that in the budget here. Plywood hurricane braces for the joists, and then hurricane braces for basically anytime two pieces of wood touch together, I'm going to throw a brace in there. And that's why I want to do this structural design stuff early on, because I can actually count out how many interfaces there are, get a brace for every single one of them, and then possibly order those parts in bulk to keep the cost down. But yeah, frankly, I don't know all that much about like residential construction. When I was working in the industry, I almost entirely did, I did entirely do commercial structures. It's like labs and factories and stuff. So basically, we'll have a bracket down here, a bracket up here for the cross members, and then whenever this intersects a cross beam on the trailer, just send a big old carriage bolt right through it. So that I also have to put on my list is to, I couldn't get. I emailed these guys back and forth for a while. Like, do you have a CAD file for this trailer? Do you have some kind of file I can use with actual measurements, like what the spacing of the joists are? So, or whatever you would call those, whatever the spacing of those cross braces are. And I was unsuccessful. They didn't have anything for me there. So, I wonder if I could put the gray water tanks, like lay them flush in this. That's a little bit different. I ended up just grabbing a design off of the warehouse for SketchUp and just kind of modifying it to fit my needs. But looking at it now, it's probably not going to be totally accurate, so I might have to go through and modify it a little bit more. My plan is to put, I think this is 7/8 oriented strand board on the outside of it, and that's what I figure is going to provide the, what's the word, that like torsional stability sort of thing. Um, that from what I read, that's what most people do. Although I did have another person on here comments on this who's building a much smaller one in Sweden, and they're on a single axle trailer. So there's going to be a big pressure point up right in the middle and like a bending moment there. So she was trying to figure out how to do that. He or she, I'm actually not sure of the gender. But yeah, the way that I'm doing it, I'm not horribly concerned about weight because 21,000 pounds is a lot. So I think that the particle board I'm using, I'm just gonna screw that to the studs and have this whole thing be this nice stable unit. So we've got bolts going down into the trailer there, like hurricane ties there. 18-inch space, or not 18-inch. It'd be. Let me make this a group so I can kind of play with this a little better without having the rest of the model in play. So I guess how does this top part work? Or do these connect to the side? I need to do a little bit more research on that. Second floor, second floor, construction. I just need a good look at how this is actually done in the real world. Let me look at the, here we go. I think it was this one. Let's see what this is. So I think what I kind of imagined this being like was more like, yeah, I don't know. I don't know. I don't know quite enough about construction, and that's part of why I'm doing this project. There's a lot of learning to be done here. So that would work just fine, where it's like a top frame and then the joists are sitting right on top of it there. How second story walls are supported. Okay. So I guess what I'm kind of seeing there, this makes a little more sense from an engineering standpoint. See if I can play with this. So bottom wall, top wall, and then the hurricane ties that, I know that something like this exists. Or maybe, I'm thinking on top. And then the second floor can just have like a joist will sit on top of the plate like I have them now. And then for the second floor, just have them offset slightly. So I'm just wondering what kind of ties I would use for that. something of that nature. Let's think hurricane ties. Interesting. So I know I had a bunch of these, and that kind of makes sense for the interface that I have here. Take a look at that. So we got running this way and connect to the one running that way. Interesting. Okay. So now we'll have some of those. Definitely have some of these too for the roof. That's interesting. So this is a really good image for me right here. We've got the studs going up in the walls, the top plate there. Oh, did you? Cool. Anything new that you can add? I was just telling the last guy about your issue with the having the single axle and the bending moment. Oh, this? Yeah. Well, I want to figure out how to make it strong. Yeah, well, ours has more of a second floor, more so than just kind of a loft. So this is really going to go. So what did you learn on Discord? Anything fancy? This is also going to have to go up to accommodate the plywood. I forget what thickness I was thinking for 23, 30 seconds, maybe. Siding. Can you use OSB for a floor? Solid slab floor that won't sag, so no, that's the answer to that. Well, maybe. Particle board is suitable only for interlocking floating floors. And there's a distinction between OSB and particle board, and I think what it is in particle board, everything's just kind of randomly splayed about, whereas in OSB, you have layers of some going this way and some going this way, and then the adhesive between the two is what gives you that extra, like, structural strength. So there's something I feel pretty good about. There we go. Kind of matches up with what I see there. Oh, not quite, hold on. Because then we're going to need another one of these. Bring that up 1.5 inches. Oh, I forgot to copy it. Yeah, it seems pretty reasonable. So we would have one long hurricane tie going from up here down to about here. So I'm going to draw that. So the ones that I saw, I'm going to have to, there are these things. Floor-to-floor connection, transfer forces from the second story to the first story. Steel plate to foundation connections, we'll have something like that. Something like these too. Definitely bookmarking that. Top plate, U-shaped dudes, the rafter to top plate. Since we have an angled roof, we'll definitely have some of those. Floor to floor, then the U-shaped dudes. Okay, so that was very informative. So these going to be a little bit more. We're probably not actually going to use this type. Not these either. I'm just looking for a long, straight piece of metal. So what situation would that one be useful in? Like coming up, only if we offset those. Definitely some of those. No, Home Depot might not be able to help me with this one. It's a foundation strap. There's the one I was thinking of. Okay. So I'm going to need a bunch of these, but these are the ones that I was kind of thinking of originally. So hurricane, braces. Yeah, so these ones definitely aren't really going to be involved with the way I'm constructing this. So let's just delete all that. Don't know how many, but they cost $1.50. And they're basically going to look like this. 18 inches long. Let's see, specifications. 1¼ inch wide. So slightly less than the width of a 2x4. So these hurricane straps are 1.25 wide. Blue axis, 18 inches. 1.25. That obviously did not come out right. that'll get you. All right, let me try that again. And that's going to be about 1/8 of an inch thick. And we're going to have a bunch of holes in it. 1, 2, 3, 4, 5. Just kind of a like a diagonal pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll call it 12 oscillations. So they'd have to be from here, 1.5 across. Am I going into too much detail? Probably. Yeah, it's not really worth my time, I don't think. Just kind of want to do something in here to represent that. Actually, if I was going to do that, I probably should have deleted the lines first. You know what? I could have deleted the lines and pushed the holes through at the same time. So let's do that. Today, SketchUp, there you go. you go? Yeah, for some reason it didn't register that these are holes in the same material. Okay, I give up. I'm just going to copy one iteration of it down to the bottom and call it a day. I can clean that up later. So there's that. So that's reasonable. And these screws are going to connect all the way through to basically all of those plates. Now we just need some at the base here. So let's take a look here. So something probably like this. No, because that's going to interfere with the where this bottom part interfaces with the trailer. But these sill-to-plate foundation connections, which are just huge square washers, probably, uh, that are going to hold the wood frame down to the flange of the metal flange of the trailer. That's going to be definitely something we need. So I figure there's going to be one of those on every one of these for each of this width here. So if this is 28 feet long, 28 feet, and this is a 24-inch on center, I'm going to need 14 of those on each side, plus 8 foot wide, so 4, 14, 28, plus another 16. I'm sorry, plus another 8. So that's going to be 36 of that setup. So let me put that in here. bolts. So the carriage bolt I figure I want to use, I'm thinking something on the order of about, say, a ½ inch, 3/8 inch, ½ inch, something like that. So let's see what we got for carriage bolts. I'm also going to need a huge, yeah, that's probably better. Something huge to drill holes. So carriage bolt, washer. Anchor bolt, so that's what that's called. 25 pack of those for 30 bucks, that's not too bad. But I'm really digging that 90-degree thing. So I think this is ultimately, I think this is kind of what we're going to go through. 5/8 inch by 10 inch. See how thick the deck of the trailer is. 8 inch, so I don't think it needs to be quite 10 inches. It's going to need to go through a 2x4, about 3/4 inches of decking, and then a little bit of metal for the trailer. So those can actually be pretty short. Something on the order of 5 or 6 inches. Let's see what options I have there. 12 inch, 10 inch, 8 inch, 6 inch. 50 pack for $37, and that would cover the entire trailer. Take a look at that. Oh, that doesn't have the washer with it. Oh, it just has this little washer. That's lame. Guess I could always use a pair of bolt cutters. I like that this is a 1/2 inch too. I don't think it needs to be. The bolt is certainly not going to be the failure point in this case. So it doesn't need to be enormous. 1/2 inch by 6 inch. So let's duplicate that tab. See if I can find me a 1/2 inch square washer. I guess this is only 8 inches thick. Oh, but that lag on that's not going to work. If this is 8 inches, that's about a 5 inch lag. So I might need some sort of spacer or something to make that work. Three-eighth inch, 1/2 inch square strut washer. That's what that's called. strut washer. The nut is going to be in a pack with the carriage bolt. And a square strut washer. So I think I'm gonna, now that I look at this, use this guy. Looks like it's got about 1.5 inch lag. Washer nut, that's gonna be on the bottom side of the trailer. Washer up here. And depending on what it looks like when I actually get the trailer, we may get a slightly larger one, but this 50 pack should do. Just the 150 pack. And it's $37. Because we're only going to need the perimeter for that. So that's not all that much. And a square strut washer. 5-pack. Yeah, that sounds about right. $4.94. We're going to need, so that's a 5-pack. And we're going to need 4 of those actually. So let's kind of see how that would look. So it's going to go up 6 inches and then over about 1 inch. I'm going to put a little bit of a radius on that, just for me. We'll do a circle at the bottom here. And that's going to be 1/4 inch. Use the follow me tool. I don't know how I'm going to represent the lag. Let's do. One and 7/8. That's probably approximately what it has. So let's make a little square washer. What's the outside diameter of that? That's interesting. Probably they're really giving us to that in feet. I don't know if I buy that. That might be the width in inches. All right, well, if that's half an inch, this is probably a 1/2 inch, 1 1/2 inch square. So let's do that. 1.5. Square strut washer, and a little hex nut. Come on, where's my center? I'm just going to rotate this twice 60 degrees to get us, after it's done saving anyway, to get us the line I can draw perpendicular to make a hex nut. You should be a face. All right, there we have it. Our little carriage bolt. So by making this a component, if I go back later and realize, oh, I need an 8-inch carriage bolt, I can just go in and stretch this by an inch. Actually, this is not at all how that's going to be. This is going to be towards the top there. And I forgot to make a washer. Come on, SketchUp. I know I'm asking a lot of my 4-year-old laptop. There's something I feel a little bit better about. I will make you metal. Let's move it here. That centers it up. And we're just going to have one for each stud. So wall cross section's coming along pretty good. And then I'm thinking we got that on one side. Immediately on the other side, we're going to have the other type of hurricane brace, the one that's was a little bit easier to find on Home Depot. Yeah, something more like that. Actually, I might already have that. Hurricane braces floor to floor. Yeah, I'll figure out how many of those we need later. Roof joists, floor joists. Carriage bolt, square corner. I don't even know what I had in mind here. That's a little lame. Just need a little 90-degree angle, dude. 10 count for, that's a little expensive. $10 for that thing, that's also very much too expensive. Corner braces. 12-gauge angle. Yeah, probably something more like this. Still $2 a piece. And it's 4-inch. 2-inch by 4-inch, so that's kind of actually wider than I can accommodate in there. 12 gauge seems enormous too. 18 gauge, 2-inch by 1.5-inch galvanized by 1 3/8. That's the one that I actually had. Okay. This little dude is probably 1.5 this way, 2 inches this way, 1 3/8 inch this way, about 1/8 of an inch thick. So this can definitely be a component since it's something that I'm going to use quite a bit of. Component, 18-inch floor to floor, it says 10. 18-inch floor to floor tie. All right, I like that. Anyway, now we're going to make a little angle dude. 2 inches there. Actually, I forget what those measurements were. 1 3/8 to 1.5. So 2 inches the bottom, which can be the top for ours. 1 3/8, 1.5. Okay, got it. 1 3/8, 1.5. 1 3/8. There's the bottom piece. We can push that up 1/8 and draw a diagonal line. Bisect that line. And we can push this guy up can be a component. I'm just going to call it a 2-inch corner brace. That's pretty good. Did I make this a component? I forgot. It's a group. I thought I made this a... Oh, that's what I did. Okay, I can explode this. And now it'll be a component. Cool. Okay. So we've got corner braces, carriage bolts. So let's start thinking about what a corner is going to look like. Well, the other thing I'm going to need is figure out how the roof attaches to that. So the roof's probably not going to be 2x6s, which I know is kind of standard for a roof. Well, I guess I should look it up. Roof joists. Yeah, we're going to need one of those plates and one of those plates. But it's not really going to overhang, although I think I could flip that around the other way. Roof joist size. How far can a 2x6? Okay, so it's called a rafter when it's on the roof. That's good info. Roof rafter size. 2x8 rafter span tables. 2x6, space 24. If the rafter in the table below, 2x8 southern yellow pine joists that have a grade of 2 of number 2, 24 inches apart, maximum span of 10 feet 3 inches. All right, so a 2x6 made of the weakest kind of wood they have is good for a 10-foot span. So a tiny house isn't any more than 8.5 feet wide, so we can use 2x6s for the roof, for the rafters. So let's copy off that 2x6. Guess I'll have to look at that again. Okay. There, that's what I was looking for. So it's a 2x6, we're going to have a beveled edge here. And then one of these some type of hurricane strap in there to keep it secure. So I'm going to play with this for a second. So I'm going to move that over to the roof just so I get the angle right. We're going to rotate, and we'll rotate about this point. That was not a rotate. Hold that to the red axis. So we are going to have to cut down this line for the rafters. Just kind of square off this end bit here. how that's going to fit because I need another 2x4 laying down on top there. I didn't want to copy there. Just a move, please. Interesting. Why would you constrain along that axis? Probably because I rotated the piece that rotated its axis with it. So I'm going to take this thing, move it straight up, 1 foot. I have no idea where that went. And this way I can saw off that end the way that we would do it in the real world. Show the rest of the model just for a moment. Oh, I know what I'm going to do there. Okay. So basically, I need to do from here out 3.5 inches, because that's going to be the height of a 2x4. And down here, then across over here. We'll push this section out. We're going to push this down 1 foot. What did you give up on? So what do you mean? Like, were you trying to get ones, or trying to adjust the ones on your trailer, or? Oh. So what issues are you running into? Kat, what's your Instagram? I'm going to do that right now because I forgot about that. Taking off tires and rims on 8 wheels. Duck. Oh, so you're talking like Jesus. You're actually taking the tires off of. So when I heard changing a tire, I was like, whoops, sorry. When I heard changing a tire, I thought like taking the tire off of the, the hub. And yeah, that's pretty extreme. Cool. Good stuff. And thanks for sharing. Okay, where was I? But yeah, actually replacing the tire without. I've never done that without taking it to a shop. Well, that's not entirely true. I did change the tire once on a Trans Am, and yeah, definitely. So welding, like reinforcing the frame so it doesn't bend at the axle, like you were talking about. Yeah, yeah, you can. My only issue with that, and I used to work in an auto shop sort of deal, um, is that potentially damaging the tire bead. Oh, okay. So yeah, you're going extreme. Yeah. So I never really liked to do mounting or dismount or removing tires without the actual tool for it because I didn't want to damage the bead or any of the stuff in the tire. So that was kind of my issue. Exactly. You're only taking this thing on your little rural back roads going whatever. So I had a tiny trailer, and I had a tire blowout on the. Yeah, no, I agree with you there. I did have a tiny trailer. Let me see if I can find that. Lifehypothesis.com. Quick plug on that. I don't know if I ever showed you guys the trailer, but it was okay. We don't have anything besides this one little trailer, but there you go. So I built this thing just kind of as a proof of concept sort of deal for just practicing my building skills. And I'll tell you what, building this arch right here was insane. But we drove it almost 5,000 miles, and then 100 miles from home, this tire blew out on a bridge. We were going about 65 miles per hour, or roughly 100 kilometers per hour, for those of you who might be in a place that uses civilized units of measure. But yeah, that was pretty disastrous. What ended up happening is some water got inside the bearing and seized it. So what's going on here? So I need to find a hurricane tie that works for actually this probably exists. Rafter to top plate connections, top plate to stud connections. So one of these things is probably not going to apply actually. for the type of roof that I'm doing, but this might work. Or something like this. In fact, I think this would be perfect. So it's going to be a little diamond. And the diamond shape is going to allow it to connect to here, 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 and then on the sides of the rafter. I'm just going to call these corner braces. Corner braces. And I'm going to make one more for rafter braces, which is 18 gauge. I don't really foresee it being any, needing anything more than 18 gauge. So yeah, something of this nature. See if I can get some dimensions on that. And I'm not sure how many of those I'm going to need for sure. And 24-inch spacing, 3/8 minimum plywood, okay. One and a half inch screws. That should work fine. Joist hangers. I considered using that, but I think that this is just going to work a little bit better structurally. This kind of situation over here. There is going to be a lot of hardware in this. Okay, so what are the dimensions of this thing? That is the question. So this isn't exactly going to apply for what we have. Yeah, this is kind of the right idea, just imagining that this is just truncated right here. Yeah, that's almost exactly what we have going on actually. So with that in mind, I think I'm just going to have to estimate the dimensions on this because I doubt that they're going to be able to give a drawing with specifics. So looking at this piece here, I would guess this is going to be 4 inches on these edges, a 4-inch diamond, and then a 3/4 inch flare. Oops. So I suppose I'll make one of those next. All right. Four inch. And I'm going to rotate that about its center point. Okay. Hit that on a 45 degree. And we need enough space for a 2x4 in there, so 0.75. 0.75. Alright, I'm going to make this a group before this gets out of hand. So what I'd really like to do, to keep this kind of real life accurate, is pivot look back at this drawing. Yeah, it looks like that totally does go to right to the halfway point. So how about we just copy this whole thing out about green axis. Oop. And we'll go 2 inches for now. And I can just take this and delete all the pieces that I don't need. And I'd like to be able to split these apart. 1 inch there. Push that through. We can make this make a group. Make that a group. Oh, and this guy needs that hole filled. Axis, 90 degrees. Then saving. Okay. All right, that is pretty darn close. I can actually delete that guy. Then I'm going to explode all of this so it kind of locks it into being one component. Make a component, and that's going to be a rafter brace. Not quite done yet. Let's go a 1/2 inch down from there, and there, one there, and I'm just going to do a couple circles in here. And for some reason, that one, oh, I see. Okay. Trying again. Okay, it doesn't like that one. I'm also going to need a couple. 1, 2, 3. Okay. Hmm. It's interesting. I'm going to make it a component inside of the group. Actually, hold on. It already is a component inside of the group, so I can explode that. And let's move this into place. Though I'm not entirely positive how. I think I got a decent idea of where it's going to go, actually. So for those of you who have just recently joined us, I'm kind of just figuring out what techniques I'm going to use to build my frame inside of the wall of the tiny house. So I've got my interior panel, fiberboard, exterior panel, and just kind of figuring out what's going in the middle of it. So the last thing I did, which I'm actually going to now make a look correct, is this little hurricane brace dude. If I grab it by that point, oh, I forgot that I did this all as one thing. Okay. I'll grab it by this point, move it in place, then slide it over 1/16 of an inch. Is that how that sits in the real world? Yeah. Looks like I kind of nailed it. So let's do a copy on that, bring it over there. So on our bottom floor down here, we've got carriage bolts going into the trailer. We've got 90-degree angle braces, and we're going to have a plywood sheathing on the outside that's going to give it like that lateral stability, like you and I were talking about. Although, I guess that wasn't an option for you. I don't recall why though. Maybe you're doing something different with the geometry of the wall. So that's kind of what this is going to look like. All right, I'm going to take a short break, and I will see you guys in a second. All right, I'm back. So, what was I just thinking? Just going to bring that down to represent the floor down here. And the trailer is going to be underneath that. I'm going to make this accurate height. How was I going to do that? So the distance between the bottom floor and the top floor, I just want to get that accurate for a second. Quick save. Work with me. From there, straight down to the floor, 6 feet 6 inches. A little tiny for a normal house, but a little perfect for a tiny house. So I'm just going to draw a line from, so it really would be the bottom of this guy straight down, 6 feet 6 inches. And then that would be to the top of this. Okay, next question is how do I make a corner? Any ideas? Because I actually don't remember. And I'm not even entirely sure what to search to find that. How to frame a wall corner, how to frame an exterior corner. Probably a good thing to look for. So yeah, I remembered something like this being a top-down view. Exterior corners there, drywall backer. They just kind of overlap and butt up against each other. Let's take a look at that. So I'm just going to take a bunch of these. Let's move that over. Red axis 24 inches. I'm going to pretend that this is my corner now. It's 24 inches on center or 24 inches between? I think it's 24 inches on center spacing. So yes, that is correct. So let's rotate that, bend that around the corner. Just gonna go 90. Then a move command just to send it in 1.5 inches. It didn't like that, 1.5 inches there. sounds like what they kind of wanted. Yeah, let me fix this. How far out does this go? Let's just do this instead. Guess I could do it down here too. Come on. Ooh, there we go. All right. So that corner. Obviously, things are going to be a little different in terms of like where that carriage bolt is, because it can't be there. So I'm probably just going to move it in just on the inside of this L bracket, or possibly not even do the L bracket there. Maybe through the L bracket. I don't know. I'll have to research on that. And then we can take this whole thing. Alright, I need you and you. And we're going to do a mass rotation there. I'm going to do it about this point. Blue axis rotation. Ah, man. Didn't register it as a rotate. Okay. Blue axis rotation. Make sure to copy it. Let's go 90 degrees. And then we're just going to do a normal move command. Kind of join these two pieces together. That looks pretty good. So the only thing that I think it needed was, so you know what? It needed an extra 2x4 in there as like a backing plate for the interior wall. Let's see if I can come up with something for that. So this guy is going to have to move in. I'm actually thinking that this anchor can stay right here. And then we'll take a copy of this 2x4. Move it in. Let's go 5 inches. Actually, it should probably be right on that corner if everything is perfect. So now from the interior, I have something to screw the wall boards to on both sides. rotation on this guy as well. Blue axis, please. To 90, then a move from there. Oh, I forgot to copy it. Let's try another rotation. I wonder if R is rectangle, O is orbit, Q is rotation. Cool. Copy it this time. Let's go 90, then a move. We're going to have to do kind of the same thing up here too. Okay, I'm recording, that's good. And this is going to have kind of the same thing going on, where it just needs an extra just going to need an extra 2x4 in there. This is actually coming out way better than I thought it would. So these members here are going to be structural per se, but since it's so close to another stud, I don't think I'm going to waste a I thought that these were supposed to be right on that. There, that looks pretty good. You can go. And that one has a brace on that side, and it's going to be directly connected to this 2x4 and this 2x4. So, you know what? Yeah, guess it can't hurt to have this guy. All right, let's push these out. That's probably the way it'll be done. Wonder if I want more of those angle brackets on the top floor. Thinking probably not, because these hurricane straps are actually going to take that load just fine. Wonder if it'll snap to the appropriate. Yeah, let's just do that. Then I can move it over here, and then I can rotate it. Blue axis. I think that would just be a 90. Then another 1/8 inch move to center it on the stud. 24 inches there. 48 inches there. Interesting. Why is that not spaced correctly? Oh, okay. I think I might have done some of my spacing wrong here. That's 2 feet. That's a 1 foot 10 3/4. Okay, so I don't think I was particularly careful with the spacing on that one. But that's not that big of a deal. I can fix that. 24 inches. Oops. That's better. Gonna need to do the same thing on this side. A little less to do on this one though. We can move that 1/8 of an inch back. That should have it all centered up. Okay, so that's a corner with a sloped roof. So I need to figure out how these guys are going to connect with the roof. We're going to need one different kind of hurricane tie for that. Yeah, I guess I don't really know how that's supposed to work. No. Sloped roof studs. Frame sloped roof. A shed with a slanted roof. That's essentially what this is, right? So the thing about this is it overhangs a little bit. I see them putting a gap up there. That's not quite what I was looking for. Let's see if... Yeah, it looks like it supports a an angled piece. This probably won't work here. Roof framing for angled wall. I am framing a tiny house with an angled end. Main structure is 24 long by 8 foot 6 wide. At one end, the wall's angle so that the end wall is only 83 inches wide. The angled walls are 30 inches long. Or 30, yeah. I want the roof plane to remain flat instead of following the angle of the walls. I guess what you're kind of supposed to do is pretty much as simple as it seems. Though I think I should square the frame out like this now that I'm thinking about it. Okay. It's definitely not worth it to do like a step here and then another short 2x4 to support the roof. So let me think about this. Let's do a rotation. Rotation right here. I guess I am going to have to rotate it by here to get the angle right. Then we can just move it in such that this meets there. We can also extend this guy up. Those meet. Do a push here. Oh, forgot to draw a line first. Do one there. I don't know why that didn't quite work. Oh, that's why. that just kind of turns that into two separate walls that adjoin each other here. So I'm probably going to need one of those like hash plate things. Okay. When I did this, I only pushed it out an inch and a half instead of 3.5 inches. So 2 inches there. And I think I did the same thing for this one. Yeah. Yeah, this definitely leaves a couple of questions about what to do here. I'm tempted to crawl up into my attic and just look. But then again, this house is almost 100 years old, so I'm sure that standardized building practices have changed quite a bit. So let me think, though. I guess the other thing that I could do would be to like cut a notch in this wood so that it can kind of do that. And part of me kind of, well, yeah, not exactly like that, but something of that nature. It kind of looks like this is what they're doing. Just going straight up and meeting up with the slant. Something about that just doesn't quite seem sturdy enough, though. Yeah, you know what? Let's try this. Just kind of playing around with ideas here. So this way I can use essentially the same technique that I was using before to secure it in place. And then we'll just have a short, just kind of like a stubby section there. And then when it gets up to the tall side, it's just another one of these all the way up to the top. Yeah, that looks pretty good. So in this case, I can get some of those U brackets. Though I guess honestly all I really need is a flat one. Like a short flat plate. Or better yet, I can just use these, but flipped upside down. That leaves a couple questions about how I'm going to do this one with like the hurricane tie. That's a pretty busy corner right there. Might be something designed for that. Yeah, you know what? I think that is legit. I suppose the only thing that might be missing is something to attach the wall to as this goes up. So in that case, it might kind of be in our interest to do something that follows this slope up. Yeah. to think about how, if I've seen that done before. I am honestly going to crawl into my attic after I'm done with this stream, just to look at this. Maybe a vaulted ceiling frame would be something that's a little more on par with what I'm trying to do here. Oh, you know what? There is something that it's going to be able to attach to this just fine if I run these 2x4s vertically. Yeah, it just seems weird. I don't know. Because if I'm going to do that anyway, why not just eliminate this member and run them all the way up to interface with that top board? Oh yeah, I forgot I was going to go all the way up with that. Yeah, that kind of feels right. So those aren't really structural, like load-bearing members there. The only reason they exist is to support the interior wall. probably be something coming down along this length. Like maybe this just needs to be put on the outside here. I mean, it can overhang on that axis a little bit. Yeah, I don't know. As for ties over here, we can actually use this one just about as easily. Yeah, I like how that ended up. Although I still do have quite a few questions about this top board here. All right, well, I think I'm getting ready to wrap things up for today for anyone who might still be watching. If you have any questions or comments, let me know. I'm just going to do a quick summary for the highlight. So to the game, the name of the game today was preparation for framing. So I wanted to figure out and get a really solid idea of how each of these wood interfaces are going to be. For example, how the second floor is going to rest on the first floor, like that. And all the parts that I'm going to use, all the 2x4s and all, so I just built a representative corner here. So to go through that, I have 6-inch carriage bolts with little 1.5-inch square washers to connect that to the trailer, and I'm going to have to drill through the trailer in order to make that interface work. A little 90-degree hurricane bracket there, going all the way around on that. Over here, the corner is framed in such a way that you can tack whatever we're using for the inside wall, which is going to be cedar boards in this case, on both sides. There's no like hanging gap there. More carriage bolts and more 90 degrees. Carriage bolts and 90-degree hurricane brackets. And then on the second floor, the interface, it's kind of treating the walls on the bottom, the second floor, and the walls on the top as kind of 3 distinct pieces. You got 1, 2, and then 3, and they're all just sitting on top of each other. So the loads that it take are just directed straight down. There's no shear loads on any of these members. It's all compression loads. 18-inch hurricane strapping going all the way down the side to hold everything together when we're moving around. And I've got the same thing as the bottom floor up here on the top floor for the corner interface. We have these little diamond things, diamond hurricane ties, to connect the rafters to the top of this wall. And again, it's acting like the roof is a separate piece from the top of this wall. It's just sitting on top. All the loads are compression loads. There's a bending load on that because there's nothing supporting it, but compression loads straight down. There's no shear loads on anything here. And that also opens us up to modular construction. These guys right here can kind of be built as one piece and slapped on top once this bottom floor is already completed. And here's another opportunity for like a modular construction sort of thing. You got all these highlighted in blue are going to be one piece, and then the roof can go on later. So now I think I have a good idea. There's just one question that needs to be answered. How am I going to make this exterior piece the last rafter? How is that going to be supported? I kind of like this solution here because it fits with the theme of only having compression loads. But if I was to put like a wall up to this, there wouldn't be anything supporting it at the top unless I custom cut a piece of wood just to justify that gap. But that doesn't really seem to make that much sense. So I might actually move this just beyond the edge of this 2x4, just so this 2x4 goes all the way to the top and it has it's entirely framed out for when we connect the wall. But that's a question for next time. Appreciate you guys all for coming out. And don't forget to subscribe if you're follow or subscribe, depending on whether you're watching me on YouTube or Twitch. I'm running the stream on both at the same time. Just to track progress, maybe learn a couple things, get some tiny house inspiration from what I'm doing here, and learn from my mistakes. All right, I'm out.